afternoon, everyone, and thank you for choosing Across the Fence. I'm Will Michael, and this afternoon for Fran Stoddard. We're on the road today at one of the largest power plants in the state of Vermont. This is the physical plant at the University of Vermont. And this facility is tucked between the library and the theater. The exterior is modest, but make no mistake, this is a powerful, powerful place. This one building supplies the heating and cooling for the historic and state-of-the-art buildings that make up the university's 460-acre main campus. Joining me is the man in charge of the physical plant here at the university. It's a pleasure to welcome Sal Chiarelli. Sal, thanks for being with us, and thanks for hosting us this afternoon.
Thanks for having me here.
So this building, this facility, has a unique and interesting history at UVM. It's one I didn't know about. So fill us in. What's the history?
Well, the building was built in 1901, and it was called the Old Gymnasium. So this was the gymnasium for the college at the time. And in the 60s, when Patrick Gym was built and the Guttison Fieldhouse was built, this was converted into Royal Tower Theater on the west side, and the east side was converted into the central plant. At the time, we just used it for heating the campus and expanded from there.
So we've gone from the crack of the baseball or softball bats to the whirling and the engines that now make this place run.
Exactly. The side of the building that the plant is in right now had a dirt floor, and there were batting cages in there, and it was used for drilling for ROTC and whatnot. So there was a term cage, and that stuck. So we call it sometimes cage heating or cage power plant. So,
Sal, how many buildings does this plant supply heating and cooling for? In other words, how much of an impact are we talking about?
Well, the campus is about 6 million square feet, and we have several hundred buildings on campus, and this heats approximately 4 million square feet, and we cool about 2.5 million square feet. And we send out steam at 220 pounds per square inch, and it comes back as condensate, and it gets reheated and turned back into steam, and chilled water is sent out at 42-degree water and comes back at about 55-degree water.
So one of the things I just want to point out, and I did know the reference to one of those figures you talked about, the square footage. And just to put a reference on that, that's over 110 football fields is the math that I did. It's just a way to put it in perspective.
Sure,
it really is amazing. So what about the staff? It takes a lot of energy and effort and manpower to keep this running, I assume.
It does. We have approximately 160 staff in physical plant, and you have to have great staff to maintain and operate these buildings, because we date as far back as 1789, our oldest building, and the newest one is being built right now, our new multi-purpose center over in the athletic complex. And we have the new STEM building and the new dorm, which has 700 beds. So, and it's all state-of-the-art buildings.
This brings up my next point, because of course a lot of Vermonters know what it takes to maintain, heat, or somehow cool an old farmhouse. So what kind of care is required, as you point out, on buildings that are 120 or more years old?
Well, these buildings each one has different characteristics. An old building, is a little basic, and the new buildings are really complex. They're computerized, they're very tight for energy conservation. So when I say tight, that means you have to have airflow that is controlled by fans, exhaust fans, supply fans. Everything has to work really up to snuff. So everything has to be calibrated, and the controls have to be perfect. It's sort of like working on a 1970s Nova and a 2020 Corvette. I mean,
it's a great analogy. I mean, these are, in terms of technology, light years apart. So again, just to go a little further, without all the engineering answer, it's just got to be an incredible challenge to be, as we look out here and see the building that's 6 months old and some, again, that are over a century.
Right, and Vermont is not friendly to buildings. So the weather really takes its toll on every aspect of the building. And every building that is designed and built on campus is unique in itself. It isn't like a car that's manufactured and you have 10,000 come off the assembly line and you can fine tune it as you go. Every building is unique, and so that means that every building has to be started up and maintained, and there's a learning curve. And you really have to go through like 2 years of winter, summer, fall, spring, where the systems get a chance to change over before you actually get the building to operate the way you want it to. So there's a big learning curve.
Look, you're a professional here at UVM. You're also a Vermonter. Vermonters care about their environment. They care about the carbon footprint. What can you tell our viewers about UVM responding to changing climate or its carbon footprint? What information can you share with us?
Well, first of all, by having a central plant, we reduce our carbon footprint by about 30%. The efficiency of having the equipment in an industrial manner here at the plant eliminates the need for building-centric systems. So you don't have to install as much capacity. So when we do projects at the plant here, it's so large that it has a big impact on our carbon footprint. For instance, when we built this new addition on the plant for central cooling, we put in what's called free cooling system, where we use the outside air temperature to cool the chilled water to send out to the buildings, so we don't have to compress the refrigerant. So in the shoulder months when it's like 45, 50, 55 degrees, where there's still cooling needs in the building, we can use the outside air temperature to cool the buildings, which is a...
And it's interesting, your response, because in some ways I might find it counterintuitive that a central, it might be more efficient to have things at the local level, but what you're saying makes sense. The carbon footprint would be significantly higher if you divided the campus into quadrants and you needed a plant to do all of that work for
Correct.
plants.
Correct. And there are so many other benefits from having a central plant, especially on the college campus. Just the noise generating and placing equipment in historic buildings. So you see the machines behind me. Imagine having to put a machine, maybe not this size, but a large machine in a historic building like Billings or Williams Hall or Ira Allen Chapel. It's hard to find the space. It has to be coordinated with historic preservation. So by having a central plant, you're just bringing a pipe in and a pipe out of the building, and then internally to the buildings, the system does its work, whether it's cooling or heating. So you eliminate all of that noise and vibration and unsightly things. Everything is centralized right in the plant here.
So do these boilers need to then run all year?
Yes. We actually make air conditioning, chilled water with our steam in the summertime. So we have in the plant here, we have 2 steam-driven turbines, the only 2 in the state. They're each 1,365-ton chillers. And we also have 2 steam absorption chillers in our health science research building. So we actually generate air conditioning with steam. And since we have our operating staff here 24/7, 365, they're professional, they're operating engineers, they know how to handle equipment. The equipment we buy here at the central plant is also industrial grade as opposed to commercial grade like you would put in a building. So these pieces of equipment could last 50, 60, 70 years with proper maintenance as opposed to 20 to 30 years with building-centric equipment. That's another benefit of having a central plant.
The other piece then, and you've referenced some numbers, I may have missed it. So we see a lot of this, look around, and you're talking about these older buildings. Well, I'm just thinking about underground pipes that need to connect and the network that exists, anybody who walks campus.
Right. So we have about 6 miles of steam piping underground and about 2.5 miles of chilled water piping that are underground, interconnecting buildings. So it's not seen at all, and that's the beauty of it. The infrastructure is hidden in many different ways, and it's hard to put a dollar value on walking through campus and not hearing some kind of pump or chiller or vibration.
Or having industrial smokestacks
Exactly.
in various quadrants
Exactly.
of the campus.
Less trucks pulling up the buildings for maintenance and operation, so it has a lot of benefits.
So you've said it, this is the newest edition, one of these chiller rooms. So talk a little bit about when this was built and the key purpose in terms of serving campus efficiently.
So when we were designing the new STEM facility and our new 700-bed first-year student housing, we needed additional cooling for the air conditioning needs in the summertime. So we were at capacity with our existing plant, so we designed an addition to the existing Royal Tower Theater / cage heating plant. So we put 30 feet on, and that's the room we're in right now. So we added capacity, and right now we're sitting on a platform that hopefully this summer we'll have another chiller, which will be a sister chiller to the one behind me, another 1,500 tons of cooling capacity. So the need for cooling with the new buildings that were being designed, it's tied into the existing system, so it works in unison with the existing chilled water system.
We've talked about some of the newer buildings. It's actually been 13 years now since the Davis Center came online. But as folks who are familiar with the campus, there have been Discovery, Innovation Hall, others that have come online even since the Davis Center. And I don't mean to repeat what we did earlier, but as those new buildings come on, how do you assess the needs and how do you minimize the impacts in cost and in carbon footprint?
Right. So when the Davis Center was being designed, that's when we stepped up and made a presentation to the Board of Trustees to install a central chilled water plant. So that allowed us to remove a lot of aged equipment in buildings, and so we put in the central plant and fed 6 buildings at the time, and that has expanded now to about 18 buildings. So sometimes you have to look at the opportunity that is coming about to make changes and have a strategic vision for the future.
Tell us quickly, with about a minute to go, about the future. What will be the future needs? What can you anticipate the future technologies that will be even more efficient than what you're doing today?
Sure. I mean, the future is bright. I mean, energy storage is big now with battery storage. There's a whole host of things that we are going to incorporate in the plant, 5, 10, 15 years from now. Some things have not even been developed. And new alternative fuels are being developed all the time. Things like I mentioned before about free cooling. So try to utilize every BTU as most efficient as possible. That's the idea of having a central plant and having a good energy management program, as well as building side efficiencies and demand management.
And we didn't even get a chance to talk about alternatives like some of the solar and things you have here, but I do need to stop us there.
Okay.
I can't thank you enough for having
Thanks
us.
for coming.
I learned a lot, and Sal Chiarelli, thank you.
Really appreciate you coming.
That is our program for today. We know you have choices, so thanks for choosing us. I'm Will Michael, inviting you to join us back here each weekday afternoon for another visit Across the Fence.